Picture a modern dogfight. It's not like the old war movies, right? It's incredibly precise, it's lightning fast, and it's often fought at distances where pilots can't even see each other. In this arena, victory comes down to microseconds, decided by a weapon that's way more powerful than any missile. And that's exactly what we're diving into.
So meet the apex predators of the sky, fifth-generation fighters like the F-35. And trust me, these are so much more than just airplanes. They're basically flying supercomputers, absolutely packed with bleeding-edge technology. We're talking everything from insane engines to stealth coatings that absorb radar. They're really the result of decades of work, all designed for one thing: to dominate the future of air combat.
But with all this incredible hardware, what do you think is their single most powerful weapon? I mean, is it their raw speed? Their crazy agility? The missiles they carry? Well, the answer might actually surprise you. It's the weapon you can't see, you can't hear, you can't touch. It's the ability to completely control the invisible battlefield that is all around us, all the time, the electromagnetic spectrum. This is the world of radio waves, radar signals, and data links. And mastering it, well, it's become the absolute key to winning a modern war. Okay, so to really get what makes these jets such a massive leap forward, we have to understand the rules of this invisible fight. We need to define the concept that governs the whole thing: electronic warfare, or as you'll hear it called, EW. Now, the official definition, I know, it might sound a little bit dry, but the idea behind it is incredibly powerful. To put it simply, electronic warfare is the art of using the electromagnetic spectrum as both a weapon and a shield. It's all about controlling the flow of information, which, let's be honest, is what every single modern military completely depends on.
Generally, EW gets broken down into three main pillars. Think of it like this: electronic attack. That's your offense. You're out there blinding enemy radar or deafening their communications. Then you have electronic protection. That's your defense. It's the shield that makes your own systems hard to attack. And finally, electronic support. That's your intelligence. It's the art of listening in, figuring out where the enemy is and what they're up to, just by tracking the signals they send.
And you know, this invisible battle is nothing new. Not at all. For as long as we've used the spectrum in combat, we've been locked in this relentless, high-stakes arms race of measures, countermeasures, and then countermeasures. It's a constant game of cat and mouse. You can see this cycle of innovation play out all throughout history. Back in World War II, the British figured out how to jam the radio beams German bombers were using to find their targets. In Korea, pilots started blinding new radar-guided defenses with clouds of tiny aluminum strips called chaff. Then you get to Vietnam, and you have these sophisticated Soviet-made missiles. So what was the response? Well, jamming pods for fighter jets, and these specialized Wild Weasel aircraft whose only job was to hunt down and destroy enemy radar. Every new threat sparks a new idea. All of this history was building towards a critical turning point in 1991. Operation Desert Storm wasn't just another conflict. It was really the moment when controlling this invisible battlefield became the central strategy for winning a modern war.
The whole guiding philosophy was this new concept called strategic paralysis. The idea, pushed by thinkers like Colonel John Warden, wasn't to just get into a long, brutal war of attrition. No, the goal was to use air power to go after the enemy's nervous system, their leadership, their command centers, and basically disable their ability to fight at all.
And electronic warfare was the absolute key that unlocked this entire strategy. Coalition forces just completely dominated the electromagnetic spectrum. Stealth jets slipped past Iraqi air defenses, jammers blinded their radar, and special missiles hunted down any system that dared to turn on. The result was this incredible information imbalance. The coalition could see, hear, and strike with precision, while Iraqi forces were left deaf, blind, and totally paralyzed.
The incredible success of this strategy in Desert Storm sent a message that was loud and clear to military planners everywhere. The future of air power is electronic, period. And that realization, it directly paved the way for the incredible aircraft we are flying today.
And you can see this evolution so clearly when you look back. I mean, the earliest jets had almost no electronic systems. Then came these basic radar warning receivers, RWRs, that just gave a pilot a heads up that they were being targeted. By the fourth generation, things like chaff and flares were standard equipment, but it was really that 4.5 generation that hinted at what was coming, with powerful new AESA radars that could track tons of targets and even do electronic attacks themselves. Each step brought the electronics more and more into the spotlight. So what is it that truly defines this fifth-generation leap? Well, it's really the fusion of three game-changing concepts. First, you have extreme low observability. You know it as stealth. Second is something called knowledge dominance.
That's the jet's ability to suck in information from all its own sensors, plus info from other friendly forces, and fuse it all together into one simple, complete picture for the pilot. And third, network connectivity, the ability to share that God's-eye view of the whole battlefield with everyone else on your team, instantly. It's not just a fighter jet anymore, it's a flying, sensing, data-crunching node in a massive network.
This total fusion of flying and information processing, it has huge implications. It gives you power that was unimaginable just a generation ago, but it also creates this really fascinating and complex paradox for the future of warfare.
There's this famous observation in the defense world called Augustine's Law number 16. And yeah, it's kind of a joke, but it points to a very, very serious truth. This level of technology is astronomically expensive. The same sophistication that makes these platforms so dominant also drives their costs into the stratosphere.
And this isn't just a theory. The trend is undeniable. You can see it right here. Each generational leap in capability comes with an exponential leap in cost. And that creates a huge challenge. How can any country afford enough of these incredible machines to actually field a capable air force? It's a question every modern military is wrestling with.
And that brings us right back to the central paradox of fifth-generation air power. The advantages are crystal clear. You have total situational awareness, and you're almost impossible for the enemy to target. But the challenges are just as stark. The cost is immense, and it's driven by software that's just as complex as the hardware, requiring constant, expensive updates to stay ahead. And that very network that gives you this godlike view, it's also a potential weakness. What happens if that connection gets broken, or even worse, gets hacked?
So we're left with one final, and I think crucial question. As the battlefield has shifted from physical space to this invisible realm of the electromagnetic spectrum, has the nature of war itself fundamentally changed? In a conflict where victory depends on information, maybe the first and most decisive shot is one that we never even hear.